Lesson 100! You did it! Or up to lesson 100, and I'm sorry I can't eat pie with you. So you'll have to celebrate this one all on your own or with your families. It is Pi Day, lesson 100, and now we get to finally use that old thing we called slant height. I told you we'd be using it eventually, and here it is in lesson 100. Because we will now understand how to find the surface area of pyramids and cones. And this is where our old friend slant height comes into play. Alright, so let's look at this. Okay, starting with a pyramid here, we unfold a square pyramid into a net. We see that we've got a base with 4 sides and 4 triangles. And it turns out that the slant height is the height of the triangle, all right? And remember that we're taking this pyramid like this and we're opening it up. And so the perpendicular distance from the base to the top, that's the height of the triangle. The height of the pyramid is from the center of the pyramid to the apex of the pyramid. 2 different numbers, 2 different things, all right? But in this case, we can now use the slant height to find the surface area of a triangle, right? Because the area of one of these triangular sides of the pyramid is going to be base times the slant height divided by 2, right? Base times height divided by 2. And that gives us one of these triangles. Well, in real life, we're not so much interested usually in the surface area of the bottom of something, all right? If I'm painting my pyramid, all right, I'm not going to be painting the bottom of my pyramid, all right? I'm not going to make my slaves lift up the pyramid so that I can somehow paint the bottom. So I don't really care about the surface area of the bottom usually, all right? However, I do care about the distance, the area goes around the pyramid, and that's the lateral surface area. We've talked about that as the wraparound area, right? The area connecting the top and the bottom, except with a pyramid and a cone, we see that this lateral surface area is a little different than the lateral surface area of a prism, where the top and the bottom match. Here, the top and the bottom don't match, so we have to do things slightly different. So, we're interested in the lateral surface area of a pyramid, and if you think about it, that's really the area of one's face, and the area of another face, and the area of another face, and the area of the other face, all added together to make the total area that goes around the pyramid. All right, the sum of the area of its sides and the sides in a pyramid or triangles. All right? So if we go back to our net of the pyramid, we see that the area of one of these sides is base times slant height divided by 2. But there's 4 of these triangles. So the lateral surface area is going to be 4 times the base times the slant height over 2, right? This is the area of one of them, and there's 4 of them. 1, 2, 3, 4, right? So that would be one way to do it, but we can be a little more clever on that and be more universal when we realize that if I take this and simplify it, 4 times base times height over 2, right? There's a shortcut here. That becomes 1, and so I get twice the base times the slant height. Twice the base. Well, if you think about it, right? B, all right? Twice the base is halfway around. The perimeter of the base of the pyramid is 4b, right? So if we say, in terms of this whole pyramid, we look at the idea of perimeter, the distance around, we see that the perimeter is 4b, but I only need 2 of those b's to find the lateral surface area. So that's half a perimeter times the slant height, which turns out to be a much simpler formula than any of this other stuff. So that the lateral surface area of a pyramid can be expressed as 1/2 the perimeter times the slant height. All right? Now, why would you use that? Well, because not all pyramids have a nice square base. Here we're talking about a hexagonal pyramid. All right? a hexagonal pyramid where it's got 6 sides. And we're going to call this a regular hexagonal pyramid. All right? And the slant height of that, they tell us, is 10 centimeters. And the length of one of the bases that's going to make the bottom of one of those hexagonal bases and form a triangle, all right, is 5 centimeters. All right? So we want to use this formula. The lateral surface area of this hexagonal pyramid is 1/2 the perimeter times the slant height. Well, the perimeter is going to be 6 times the base because hexa, all right, hexagonal means 6 sides. So I got 6 sides and each one of them is 5 centimeters long. The perimeter equals 6 times 5. So the perimeter is 30. All right. The slant height, we didn't have to use the Pythagorean theorem to find it. They just told us it was 10 centimeters. All right. So now the LSA equals 1/2 of 30 times 10. Substituting in for P and S. And I can do 30 times 10 and get 300 and take half of that. Or I can do half of 30, 15 times 10, 150. Or I can do half of 10 times 30. Any way you look at it, you get 150. And since it's area, we're talking square units. And the units, they tell us, are centimeters. So the lateral surface area around that hexagonal pyramid is 150 square centimeters, using this formula. All right. Now we look at cones instead. Cones have a radius. They have a distance from the center of the circle to the apex called the height, and they have a slant height as well. All right. Cone, this line here is the slant height, which is different than the height. Remember. All right. We use the Pythagorean theorem to find that slant height because the slant height is the hypotenuse of the right triangle formed from the radius and the height. All right. So the idea is, what formula can we use for here? If we start off with 1/2 the perimeter times the slant height, the perimeter of the base is a circle. So the perimeter is pi times diameter. So if I substitute in for perimeter, diameter times pi, and they usually just give us the radius, so if we want to put this in terms of radius, then it's 1/2 times twice the radius, because the radius 2 radii equals 1 diameter. So now I can write this as 1/2 2r pi s, all right? But half of 2 is just 1, so the numbers go away, which is nice. And it says the lateral surface area for a cone is pi r s. Pretty simple, huh? So we could do that. We're given something like this with a tricky extraneous value here for height, which we don't need. All right. So we see that the lateral surface area, the distance, the wraparound distance, all right, wraparound area for the cone. Remember, that does not include the base. All right. This is just the wraparound part. All right. Is pi rs. So they tell us the diameter here is 10, trying to trick us, all right? We're not going to use 10 because the diameter is twice the radius. So if the diameter is 10, we see the radius is half of that, 5. So now using substitution, the lateral surface area is pi, 5, and that gives us the slant height of 13, all right? So the lateral surface area equals 13 times 5, 65, yeah, 65 pi square, and it's centimeters, right? And since it didn't tell us what to do with pi, we're going to leave pi as pi and have the area in terms of pi. And if they wanted 3.14, then we do 65 times 3.14 on the calculator and still get the same number of square centimeters, pretty much. Right. So that's the idea of lateral surface areas of cones and of pyramids. So lesson 100, our pi lesson. Your assignment is A to D, and believe me, if you do A to D, I guarantee you're going to get a 100 on it. And part of your assignment is also to eat some pie. So enjoy your pie as you enjoy lesson 100.